Here we have a problem on quadratic equation. Okay, let's go the information. If the roots of the equation x square positive 2p negative 1 times x positive p square equals to 0 are real, then which of the following is true? Okay, here we have a quadratic equation and the question says the two roots of this quadratic equation are real. Then we have to find the one which is true among the given answer choices. Okay, now let me consider a quadratic equation in standard form, that is ax square positive bx positive c equals to 0. Actually, we consider this quadratic equation in standard form because we have all the terms on one side of the equation, on the other side we have 0. Okay, if this usually we have two roots for a quadratic equation. If a quadratic equation has two real roots, then the value of the discriminant b square negative 4ac has to be greater than or equal to 0. Okay, now we can use this concept in our quadratic equation because the two roots of the given quadratic equation over here are real. Then when I get the value of the discriminant b square negative 4ac for this quadratic equation, it has to be greater than or equal to 0. And also before that we must be aware of what is equal to a, b, c. Actually, a is the coefficient of x square. In this case, there is no number in front of x square. So I have to assume there is 1 as coefficient of x square. There is a value of a is 1. And the b is the coefficient of x. In our quadratic equation, b is 2p negative 1. And c is a constant term. In our quadratic equation, c is p square. Okay, now let me write this stuff first. We have a equals to 1, b equals to 2p negative 1, which is a coefficient of x, and c is p square. Okay, as I said already, since the given quadratic equation has two real roots, the value of the discriminant b square negative 4ac has to be greater than or equal to 0. Now we can plug in this 2p negative 1 for b over here. Then I'm getting 2p negative 1 the whole square negative 4 times the value of a is 1 and the value of c is p square greater than or equal to 0. Okay, now to simplify the expression we have on the left side, I have to expand the square of the binomial over here. For that, let me consider the algebraic identity, that is a negative b the whole square, that is the square of a binomial. Its expansion is a square negative 2ab positive b square. Okay, when I compare this one and this one, at the place of a I have 2p, at the place of b I have 1. So to get the expansion of this one, I just have to use a trinomial over here. So in this trinomial, at the place of a I have to write p, at the place of b I have to write 1. Okay, let me continue over here. When I write 2p at the place of a, I am getting 2p the whole square negative 2 times ab. 2 times a is 2p and the b is 1 positive 1 square. Negative 4 times 1 is 4. 4 times p square is 4p square greater than or equal to 0. Now let's simplify this 2p the whole square. Here inside the parenthesis 2 and p are multiplied and we have the exponent 2 in common. Whenever two terms are multiplied and we have common exponent, what we can do is we can distribute this exponent to each term over here. Then I'm getting 2 square times p square negative 2 times 2p is 4p. 4p times 1 is just 4p. Positive, the value of 1 square is just 1, negative 4p square greater than or equal to 0. Okay, the value of this 2 square is 4, so we can write this 2 square times p square as 4p square negative 4p positive 1 negative 4p square greater than or equal to 0. Here this positive 4p square negative 4p square will cancel out. Then I'm getting negative 4p positive 1 greater than or equal to 0. Okay, now according to the answer choices we have over here, we have to solve for p. For that we have to isolate p in this inequality. Okay, first let me get rid of this positive 1. For that let me subtract 1 from both sides, and positive and negative 1 will cancel out. Then I'm getting negative 4p greater than or equal to negative 1. Okay, now to solve for p, I have to get rid of this negative 4 which is multiplied by p. So for that I have to divide both sides of this inequality by negative 4. Then I'm getting negative 4p divided by negative 4. On the right side negative 1 divided by negative 4. Okay, whenever I multiply or divide both sides of an inequality by the same negative number, I have to flip the inequality sign. Already it's greater than or equal to 0. I have to flip it to less than or equal to, because I divide both sides of this inequality by the same negative number, negative 4. So here this negative 4 will cancel. We just get p on the left side less than or equal to. So this negative will cancel out. I'm getting 1/4. Okay, so here when the given quadratic equation has two real roots, then we get p less than or equal to 1/4. We find this stuff in answer choice D. The correct answer choice for this question is D.